Hello, good morning all. Today we are going to start. We are going to study the last portion of the image formation. So next one which we are going to study, when the object at the principal focus, you can see here that the object is at the principal focus of a concave mirror. So we know that when the light ray which is parallel to the principal axis, the light ray which is parallel to the principal axis, after reflection it will pass through the principal focus, you can see here. Then the light ray which is moving in the direction of principal axis, center of curvature, that means the light ray which is move, which is striking in the direction of center of curvature, then after reflection it will reflect back and moves through the same path, you can see. So here two ray of lights we are considering. First one, the ray of light which is parallel to the principal axis, after reflection it will pass through the principal focus. And second one, the light ray which is in the direction of center of curvature, after reflection which will reflect back in the same direction. Then look at these two ray diagrams. You can see here that both these ray diagrams are parallel to each other. We know that if we are taking two parallel rays, means it won't get converged or it won't get joined at any point. So if the light rays converge, then only we will get the image. So here means these light rays will move like this. So we are saying that we will get the image at infinity. We will get the image at the point infinity. We will not get at a beyond C or anything. We will get the image at the point infinity. Then is it a real or virtual image? Yeah, obviously it is real, because the light rays will converge at the infinity. So the image is real. Then second one, is it erect or inverted? Obviously the image is in the opposite direction of the object, so it is inverted. The image is inverted. Then what about the size? Yeah, we can see here that object is only this much size, but if we are taking the image which is moving to down again and again, so the image is highly magnified. So I hope you understood. So we will get the image at infinity when we keep the object at a principal focus. Then the image would be real, inverted and highly magnified. I hope you understood. Then next one which we are going to study about the when we keep the object in between principal focus and pole. Okay. So if you are taking a concave mirror, my diagram is not that much clear, okay? Center of curvature, principal focus and pole. So if we keep the object in between principal focus and pole, then you can see here that the light ray which is parallel to the principal axis, after reflection it will pass through the principal focus. That's we already know. And second thing, once again, then second one, the light ray which is moving in the direction of center of curvature, when it reflects it will move back through center of curvature. You can see here. So in here, you just consider these two light rays. These two light rays are like this only. Correct. Both are not parallel. They are moving away from each other. So we can say that these two light rays will never get converge at any point. So what we'll do? Yeah, in this case, we have to extend the reflected light rays, not the original light rays. Okay, we have to extend back the reflected light rays. You see, so if we extend the reflected light rays, then we at this point you can see both the light rays. This extended light rays will denote with the dot lines, okay, not with the straight one. So if we extend by the reflected light rays, at this point both the light rays will get converge. So we will get the image at this point, means we will get the image behind the mirror. Then first question is it a real or virtual image? So if the light rays get converged, these reflected light rays, if it get converged, means we can say that that is a real image. But unfortunately in this case both the light rays are getting diverged. So we but when we extend back the light ray, reflected light rays, then at one point both the extended light rays are getting converged. So in here the real reflected light rays are not converging. So the image would be virtual. I hope you understood. Yeah, the image is virtual. Then second one, is it erect or inverted? You can see here that both the, if you are comparing both the object and image, both are in the same direction. So we can say the image is erect. Then third one, what about the size? We can see here that the image is bigger than the object. So we can say that the image is magnified. Okay. Yeah, next one which we are going to study about the image formation by the convex mirror. So first one, when we keep the object at infinity, we know that convex mirror means the outer surface is polished and inner surface would be rough. So when the object is at the point infinity, then when if the light rays are if the object at infinity, then the light rays always will come parallel to the principal axis. So the light rays which are parallel to the principal axis, we know that what will happen, it will reflect back in the direction of principal focus. Then the light rays, here also the light rays which are striking or which are coming parallel to the principal axis, after reflection it will moves away from the principal focus, moves back in the direction of principal focus. So you can see here that both the reflected light rays are moving away from each other. These two light rays are not going to converge at any point. So if we extend back the reflected light rays, at this point both the light rays will get converge. Means at the principal focus both the light rays will get converge. So where we will get the image? we'll get the image at a principal focus. Then what are the characteristics of the image? Is it real or virtual? Yeah, obviously it is virtual image. Then what about this one, size? Yeah, both the object and the image are in the same direction, so it is erect. Then what about the size? Yeah, the object is very big and image is at a, we are getting the image at one single point. So we can say that the image is highly diminished. Okay, I hope you understand. So next one, if you keep the object at any point of the convex mirror, we will get the same image only. Means suppose if you keep the object at a point center of curvature or at any point, we will get the same image. So we are just going to draw it, principal focus, pole, principal focus and center of curvature. Then if we keep the object, in case if you are keeping the object at this point, then at any point if you are keeping the same image only we will get. Clear? Then the light rays which are parallel to the principal axis, after reflection it will reflect back in the direction of principal focus. So you can see here. Then the light rays which are coming in the direction of the if the light rays are coming in the direction of center of curvature, if the light rays are coming in the direction of center of curvature, it will reflect back in the same direction. So we already studied those laws and all. Then you can see here that both the reflected light rays are moving away from each other. So if we extend back these light rays, then we will get the image. Correct? Yeah. Sorry, not this point, okay? If we extend back the light rays, then we will get the, you can see at this point both the light rays will get converge. So the image is first one, where we will get the image, we will get the image in between pole and principal focus. Then second one, is it a real or virtual image? Obviously it is virtual. Then third one, what about the side, this one? It is erect or inverted. Both the object and image are in the same direction, so which would be erect. Then what about the size? The image is smaller than the object, so we can say that the image is diminished. So this is about the drawing of the ray diagrams. You have to write it on your copy and you have to study it. Clear? Then next class we are going to discuss the problem part of this chapter. Okay, so before that please study it and finish it. Okay, thank you.